This is the fourth video in the user-specified statistics module, and in this video we'll look at a second class of user-defined statistics that are time-dependent statistics, or to use the semio terminology, state statistics. And so the model that we'll use is the same model that we have been using for the previous videos from chapter 5 of the textbook, which is the printed circuit board placement model that you see running here. The statistic we're going to look at first is the number of entities in the system. So as the system runs, you can see that entities arrive, they go through the processing, sometimes they go through the rework and loop back, but eventually they leave through either the good or the bad sink. And one of the things for systems like this that we're interested in is the number of entities in the system. And so if I stop the run right here, you can see that there's an entity being processed at inspection. There's another entity in the queue, there's an entity being processed at placement, and there's also an entity in its input queue also. So at this current simulation time of 2.57 hours, the number of entities in our system in this case is 4. So we look at that statistic, at what we're measuring, we can think of this as a time function. So let's look at a table here, and let's just say that we're going to observe the number in system at time t. And so our system starts running, and here we are. Let's just assume this is time 0. It runs for a while. First entity arrives, then it runs for a little while. Let's say the second entity arrives, runs for a little bit longer. First entity finishes, runs, second entity arrives, third entity arrives, fourth entity arrives, then maybe 2 depart at the same time, and then another departure, and so on. And so we end up with this time function where at any point, like right here, t, this is NIST. Oops, that function at time t. So what we're interested in doing is collecting these values or observing these values so that we can then predict, or we can observe performance metrics like the average number over time and things like that. So the process that we'll follow has 3 steps. First of all, we have to define NIS. In other words, we're going to use a model state to capture at any point in time how many entities are in the system. The second step is to tabulate the values of NIS, NIS as the model runs. And the third step is to tell semio to compute or to track NIST. So in other words, we've defined a value. We've defined a model state called NIS. We've then updated that value during the run of the simulation appropriately, and then we tell semio, I want you to watch this value over time. So for the number in system time dependent statistic, clearly this step 2, we increment the value whenever an entity arrives, and then we decrement the value whenever an entity leaves. Before I demonstrate this in semio, I want to make one quick statement about this notion of a model state, as we said for NIS. In the previous videos when we were looking at observational statistics, for example, the time an entity spends in the system, we defined an entity state because the time in system is a characteristic of each individual entity. And because it's a characteristic of the entity, I need to use an entity state to track that value. The number in system at any given time, however, is a characteristic of the system as a whole. Therefore, instead of an entity state, I need to use a model state. So let's go back to our model and demonstrate this 3-step process. So the first thing I need to do is define the the model state that we called NIS. So I'm going to go to the model, definitions, state, and I'm going to define an integer state, and I'm going to call this integer state NIS. NIS, as we did in the diagram. It's an integer state variable. I know that it's an integer state because what I'm tracking is the number of entities in the system. So that is a discrete value, and so we'll use an integer. The second step is to update that value or to tabulate or calculate the value as appropriate. And of course, as we said, when our model's running, if you watch the model run, if we are interested in this numbering system, we need to increment the value of NIS here when entity arrives, and I need to decrement the value here when entities leave. And so I'm going to go to the source object and use the state assignments that I did before. So I'm going to, on the before exiting, you can see in the model, this is where we marked the model entity. So we set the entity time. I'm simply going to add a second value here and say NIS is equal to NIS plus 1. And so now when an entity arrives, we should increment that NIS value. So the next thing I'm going to do, as we typically do, is we're going to create an animation object that helps us make sure that the model is doing what we think it does. So I'm going to have a status label that just shows NIS. And so what I expect to happen when it runs is I should expect this value to increase whenever an entity arrives. We haven't yet set the decrement, so this value, NIS, should continue to increase throughout the run. So if I just run to the end of 100 hours, of 100 hours, the run length, we can see that we have 1,008 entities. Now the second part again of calculating our values, if we are interested in the number in the system at any time, is we have to reduce the value when entities leave. There are two simple ways I can do that. I could use a state assignment on the sinks. I would use a state assignment on the bad sink and a good sink, just like we use state assignments on the source, except instead of incrementing the value, I would decrement it. Or I could use an add-on process. We already have an add-on process that we use to record the time and system, so that's the approach I'm going to take. Here are the two tallies that we did in the previous videos, and to that process, I'm just going to simply add an assign step and do the decrementing. NIS is equal to NIS minus 1. And now when we run our model, we should see the value in our status label will reflect the actual number of entities in our system. And so we can see that it's going up and going down and so on when entities leave. And so we hope, when I make this run a little bit faster, and I just pause it at an arbitrary time, and we see we have one entity in the system and the value is, of course, 1. If we continue to run and sample more, we can then see, ensure that the model is doing what we think it's doing. So the third step, we've done steps 1 and step 2. We defined NIS and we tabulated the values. The third step now is tell Simio that I'd like to track the number in system as a function of time. And we do that by defining a state statistic. So I'm going to go back to the model, the definitions, the elements, where we have our two previous user specified statistic. This time I'm going to create a state statistic, and I'm going to call this state statistic number in system. And when I define the state statistic, in order to tell Simio that I want to track that over time, I just have to specify the state variable. In this case, our model state, NIS, that we defined previously. And so now when I run my model, so let's run it for a little while, and now let's just run in fast forward mode, go to our results, we can see in our user specified statistics area, we have this new statistic number in system, which is a state value user specified statistic, and we get the average, final, and maximum value. In this case, average 7.769. And as I said, Simio automatically tracks this for populations of entity instances, so that value is here 7.769 as we saw before. So as with the tally statistic for time in system that we computed earlier, if you're interested in the number in system, then we have no need to do this user specified statistic because Simio gives that for us automatically. However, the general process that we followed, this notion of defining a model state, updating that value appropriately, and then telling Simio to track it, is the standard mechanism that we'll use for monitoring or for measuring time-dependent statistics. And the difference between these statistics will be in step 2 as to how you update the values. And in the next video, we will do a similar statistic that Simio doesn't track for us automatically, and so we'll see the general applicability of this method.